So in this video, I'm going to show you how to use simple and multiple regression in Stata. Something, just sort of a disclaimer here is please don't take what I'm showing here to suggest like how to select the right way to select variables, or that this is even a great model or anything like that. So everything I'm going to show here is just for demonstration purposes to show how the regression command works in Stata so that you can get some results. So to start off here, you'll see that I have Stata already up, and I've got some data loaded, as you can see over here on the right. So this is school level data from the state of New Jersey for the 2019 school year. And let's say, just for the sake of demonstration, that the topic that we're interested in exploring is about the differences between, or whether charter schools or TPS, traditional public schools, are higher or lower performing. So are charters higher or lower performing than traditional public schools? So that's sort of the topic. So what we would first need to do is operationalize that into some research questions that we can generate some hypotheses from, and then run some analyses. So let's start by picking. When we say more effective, we have to decide what that means. So let's say that we pick third grade reading proficiency. That's going to be the outcome, the dependent variable that we're really interested in. And then let's say that, well, along with just whether a school is charter or traditional public school, then maybe some other things kind of matter for this third grade reading proficiency outcome. So let's say that we want to consider that student characteristics might have a role to play here, and some teacher characteristics might have a role to play here. So what I've done ahead of time is I've just picked a set of variables that we're going to use here. So first off, I've got this variable here, ELA underscore med exceed. So this is the third grade reading proficiency variable. Charter here is a binary variable. So this is our, sort of the main thing that we're interested in. So a 0 here means that it's a traditional public school. A 1 means that it's a charter school. Bachelor's teachers, so this is the percentage of teachers in a school for whom a bachelor's degree is their highest level of education. So the inverse of that would be a graduate degree of some sort, because you have to have at least a bachelor's to become a certified teacher. Then teacher experience within school, the percentage of students who are chronically absent, and the percentage of students who are economically disadvantaged. So you always want to make sure that you've looked at your data first. So in this case, I have, but just to show you, like, at least make sure that you run some descriptives so you can take a look and make sure that you know how everything is measured and what the variables look like so that you can interpret them correctly later on. So these are our 5 variables that we're interested in. So this is a percent, but it's a percent in a whole number. So 51 means 51%. Looking down here for charter, so this, and sorry, for the reading proficiency, we can also see, because the minimum is 10, so the lowest school is 10%, max is 100. For charter, so we already mentioned that this is binary, but we can see that here as well. So 0 means traditional public school, 1 means charter. 0.035 in this case means about 3.5% of the schools in our data set are charter schools. Looking here for bachelor's, so this is measured in, this is a percent, is a whole number. Teacher's average experience, so this is actually in years, so 11.98 means on average an average of 11.98 years of experience in their school. Then same chronic absenteeism, so this is a percent, is a whole number, so 9.7 means on average 9.7% of students at schools are chronically absent. And then we can see the standard deviation and then the range over here. So now that we've taken a look at this, so we know how to use this data appropriately, let's say that what we want to do is run a simple regression that just uses one predictor. So simple regression, you've got one predictor, one independent variable. So what we're going to do is we're going to use the reg or regress command. And so we're going to type in our outcome variable. You always put your outcome or your dependent variable first. Then we want to add our independent variable of interest. And when you're adding independent variables here with the regress command, you always want to specify whether this variable is a categorical variable or whether it is a continuous variable. Stata will run regardless of whether it's categorical or continuous, but the results you get might not be correct if it's a categorical variable and you don't specify that it is. Stata will always just assume that the variable is continuous. So here's how we declare whether a variable is categorical or continuous. In this case, charter, it's a binary variable, which is a type of categorical variable. So we just type I dot. And now we've declared that this is a binary variable, and we can just hit enter. So we've got some results now. So what this gets us is we've got an ANOVA table here. We've got our some fit statistics over here, some model statistics in the top right, and then we've got our coefficient table. So if we just jump to our coefficient table, so this is a binary variable. So when we're doing something with a binary variable or any categorical variable, Stata is going to pick a reference category. By default, Stata will always pick the lowest value of your categorical variable as the reference value, which in this case just means that traditional public schools are the comparison. So the way that we would interpret this is, relative to traditional public schools, students in charter school or third graders in charter schools have reading proficiency rates that are, it's about 3.5% lower. If we go over here, this column has our p-value. So the p-value is 0.174. So this is not statistically significant. So this difference of 3.5% about is not statistically significant. And so then if we jump up here and look at the model statistics, so we've got number of observations. So this tells you how many observations were used to compute this regression. And so we have 1319 because there are only 1,319 schools that have a value for third grade reading proficiency, because high schools wouldn't have this. And so if a school is missing any variable in your model, then it gets dropped from your analysis. So that's where our number of observations comes from. If we look at the p-value for our F statistic, we see 0.174. So what this means is that the model doesn't explain meaningful variation in our outcome, which is not surprising because we have one variable, and that one variable is not statistically significant, so not surprising. And then we can see what our R squared is here. So then let's say that what we want to do is we want to add some more independent variables to better get at this comparison, to isolate really the difference between charters and traditional public schools. And let's say that we think, well, charter schools might have different kinds of teachers. Charter schools might serve different kinds of students, and we would want to account for that so that we can better isolate the difference between charter schools and traditional public schools. So now let's say that we want to run a multiple regression. So what we want to do is we looked at just a simple difference in means here, and we don't think that that's all that helpful. Say because we think that charter schools and traditional public schools tend to have different kinds of teachers. Charter schools and traditional public schools might tend to have different kinds of students. And so what we would want to do is account for that so we can better isolate this, charter versus TPS contrast. So what I've done is I've typed in, some stuff down here, and I just had this saved in memory and pasted that in so that you didn't have to watch me scrolling through the variables viewer over here or typing everything out. So it's the same command. So the difference in Stata, the difference between running a simple regression and multiple regression is just how many independent variables you add on to the right. So same command, reg, then you always put your outcome, your dependent variable next, and then you can just keep adding independent variables. So again, these are the independent variables that we want to use, but we need to go through and make sure that we declare that, charter is a binary variable or is a categorical variable. All of our other variables are continuous, and we can just specify that by typing C dot in front of all of them. Now I can just hit enter and get a new set of results. So you see the results have the same basic setup. We've got our model statistics up here in the top right. We've got our coefficient table right here below, and usually this is where the answer to our research question is going to lie. But first, you might want to just double check your model statistics, right? So this has 1,312 observations. So what that means is that there were 7 schools from our first model who are missing at least one of these other independent variables. So they were dropped from the model. That's important to pay attention to because sometimes when you add independent variables, you might start losing schools really quickly. And so you want to make sure that you're not dropping a bunch of schools. You're not losing a bunch of statistical power by reducing your sample size. Then we go down here to our the p-value for our F statistic and say, oh, it is statistically significant, which means our model is actually predicting some variation in our outcome in third grade reading proficiency. Then we've got our R squared, and in this case means that our model, our set of independent variables here is explaining about 54% of the variation in third grade reading proficiency rates. because you can convert 0.54 to a percent, just move the decimal place. And so that now we've got a set of 5 different independent variables. And in this case, because this topic that I've just kind of used for demonstration purposes, we're really just interested in the coefficient and significance for this variable right here, the binary variable that says whether a school is a charter school or a traditional public school. But we could interpret these other things too, because usually if you're using something as a control, you're not interested in it. You're using it to explain variation, but it's not something that you need to interpret to answer your research question. But just, to show how we could do that, what we can do is let's take economically disadvantaged students. So this is a percentage, is a whole number. So what we would say is that after accounting for these other independent variables in the model, a 1% increase in the share of economically disadvantaged students in a school is associated with a 0.37% decrease in third grade reading proficiency. And so I said 0.37% decrease because this is negative. And we say that decrease is in our outcome, third grade reading proficiency. Then we can go over here to our p-value and see that it's 0.000, which means that this is statistically significant and we can reject the null hypothesis. So we could also go up to, say, this teacher average experience variable. So this is measured in years. So we would say is after controlling for the other independent variables or accounting for the other independent variables in the model, 1 year in average teacher experience in a school is associated with a 0.08% increase or gain in third grade reading proficiency. But if we go over here to the p-value, we see it's 0.6, which is greater than 0.05. So we fail to reject the null hypothesis, and that means that this is not statistically significant. So we could do that for all of these, but in the case of this topic that I'm using for demonstration purposes, really this is what we want to use to interpret. So what this means is that relative to students after accounting for these teacher characteristics and these student characteristics, students in charter schools relative to traditional public schools have a third grade reading proficiency rate that is about 12.4% higher. And when we look over here at the p-value, so this is 0.00, so that is less than 0.05. So this is a statistically significant difference. And so that is how we can use simple regression and multiple regression for a continuous outcome in Stata to get some information that we can use to answer a research question.